we'll go into the demo as well. So yeah, basically it's the stuff which is there. It's open source, though we have an offering, but this particular thing you can also try on your desktops in the Docker environments as well. So you will be able to try that. So basically, we are talking here about Talos. Now, before getting into Talos, you can see, from where we are coming and where we are going. You can see, we had monolithic apps, and the process was ordering hardware, configuring the operating system, configuring and deploying the application, and then maintaining the application. So this was the whole process that we were following: single app, packaged, and then deploying. Then slowly, the microservices era came, that you can write in your own language, easy to scale, independent services. Do not build the entire application if there is only one microservices or a small piece of change in single API, and more into the API driven approach, independent scaling of services. Then moving into the cloud native and containers era, containerizing these applications so that they can be distributed across any cloud, any platform, making it run as with the orchestrator like Kubernetes, so that it can manage hyperscales, it can manage dev stage, prod, hundreds of microservices deployed as container, and you can get auto scaling out of the box, and bunch of other features. So this is where we are. So we know, like, microservices are cool. We still write monolithic applications, it's fine. But most of the time in the cloud native way of things, that means cloud agnostic. That means you write the application on one cloud, and you should be able to port that application across cloud if you want to. That's your choice. So it's all about flexibility, scaling, and making ease of development and deployment. So current flow is like bare metal host operating system, setting up Kubernetes, deploying microservices. It is actually still the current flow. You either even if you choose managed Kubernetes from any cloud provider, they will be having their own virtual machines or their own operating systems, which CentOS, Ubuntu, whatever that traditional, I would say, that traditional OS is that they're using, setting up Kubernetes and giving you, or you will be doing it by having the VMs and setting up the operating systems on that. Now, the problem here is we have evolved in the way we write the application, and now we have WebAssembly. So we are evolving in the way we write the application. We have evolved the way we write functions and have individual components of the application. But we haven't evolved much in terms of the operating system. We still see we have the same operating system, CentOS, Debians, which were never meant for the containerized workloads. Like, they were not only built for these type of workloads. So that's where there are few challenges. So why do we need the whole operating system to run Kubernetes? Because Kubernetes needs, kubelet and some of the other minimal binaries to run. And if running Kubernetes is the sole purpose that you want to give to your customers, then probably that only should be the case. And if you have any other thing, you can always have a Ubuntu instance or whatever flavor of operating system you like. So you have that. Now, the issue is OS upgrades and security patches. So the problem, we have OS upgrades, we have security patches, which are not very much consistent with the Kubernetes ecosystem, which are not consistent. You have to manage on your own, and it's a pain for whenever there's an issue or a vulnerability comes in. And we have seen the rise of vulnerabilities and security vulnerabilities in the past few years. They are like exponentially increasing. So the OS upgrades and security patches are a huge pain. Then the OS version, like maybe your application which runs is on a specific operating system, and if you try to run it on another specific operating system, which is not, you are running Kubernetes, but in the beneath you are using different OS systems, that can lead to inconsistencies. And this is where Talos comes in. So Talos is actually an API-driven Kubernetes-based operating system written from scratch. Yes, one of my friends, Andrew, has taken the courage back in 2015, 2016 timeframe to write an operating system from scratch. Like, how cool is that? In that particular era, writing an OS from scratch. It's a big thing. And it has proven to be really, really well, really, really successful, because that we'll see that. So it's API driven, it's image based, it's atomic upgrades. So it never breaks. the upgrade, either it does or it fails. So it never in between, like updated few and then didn't update other few. So it's atomic upgrade. The biggest thing is there is no SSH, no unnecessary binary, no system D. So there is none of those that can lead to any of the security attacks. So if I just give you a brief, feature overview. So you have declarative YAML file. So it's more Kubernetes way because it is meant for Kubernetes. It's a Kubernetes native OS. So you can, and you can choose your own CNI. You can add extra flags if you need, specific kubelet configuration or specific kube API server configuration, but all those you specify in the config file. You have your role plane and health checks that you can do. 100% it is Kubernetes certified distribution that runs on it, and you can boot up Talos. So you have Pixie booting, everything is there. It's an image that you can boot up your Raspberry Pis, within like 2-3 minutes. You get a Kubernetes cluster up and running with Pixie booting. So you have, and reduced number of CVE. It automatically follows the Kubernetes CIS benchmarks, and the CVE is automatically reduced because there is no limited OS dependencies, and it's also reduced to a way to that context that there's no SSH. So someone cannot natively SSH into the system. Even your own team cannot SSH into the system and do something that, the Kubernetes workflow. So I think it's pretty rad. And that's why it's very popular in the Kubernetes and the cloud native ecosystem. And these are the libraries, these are the 12 binaries. Sorry, these are the 12 binaries in Talos Linux. So that's the latest blog that they just published, and I took the image. I really liked it. So you can see containerd, LVM in it, all the 12 binaries which are there. That's it. That's enough to run Kubernetes. Now, one more thing is sometimes what happens is you might have to run your custom runtime. You might need a hardware dependency, or for the GPUs, you might need NVIDIA drivers. Since it is not like the itself is open source, but it's not customizable in a way that you can, do everything inside and then create an image and stuff. So they created something called system extensions. So they created Talos Linux system extensions that where you can add specific libraries and the binaries that you need, and you will be able to drop that on the system and add that as an extension to the Talos operating system. And that's what we exactly did with WasmEdge. So if you see the official repository of Talos, so I contributed back to the Talos community. So in the extensions container runtime, we have now WasmEdge as the extension. Let's try to see where it is. Here it is. So this is the WasmEdge extension. And if you see, it's a simple manifest file. And then you have your PKG. This is the important file. So what it's doing is it is actually downloading the shim from the runwazi official containerd runwazi repository. So you can see it is downloading the official shim with all the checksum downloaded, all the checksums being verified, and then it is creating the directory and unpacking it, and then putting that as part of the, and also setting up the containerd.toml file by adding the wasm part. And part is something which is just the plugins IO containerd CRI and container runtime as WasmEdge. And here we specify the runtime type. That's the standard when you want to run WebAssembly workloads on Kubernetes. You need to have a shim, and then you need to update the containerd.toml file so that whenever you have the runtime class as WasmEdge, it's able to use WasmEdge binary, WasmEdge shim to run the WebAssembly workloads rather than the run C shim. So that's the only thing, and that's what we have done. So you can run the extension easily. If you can run Talos, you should be able to run this extension as well. It's pretty simple. This is the talos.dev. They have like amazing documentation and CNCF certified. You can see, read and try it. What I have done today is Civo provides a managed Kubernetes offering based on Talos. We are the first and the only provider who provides Talos-based Kubernetes for the people. So I have already created a new cluster called Wasm Talos. I mean, even if I create now, it will just take 2 minutes because that's the power. So kubectl get nodes. And you can actually see it was just before this call that I created it. So yeah, just 49 minutes ago, I created this cluster. Kubectl get pods. We don't have anything yet. This is a simple cargo file that I created, like a simple Rust application. And you can see cat source. I have had, I have just added hello WasmEdge community, and that's pretty much it. And then I have Dockerized it. So you can see the Docker file as well. Sorry, Docker file. So you can see it's a scratch image. So what it's doing is running cargo build target WasmEdge, Wasm32 Wazi release, and then copying the source target Wasm file and then putting it as the entry point. That's pretty much it that it's doing. And then comes the deployment file. So deployment file is simple. First, you need a runtime class. This is the one-time operation. So once you have the runtime class, you can run your WebAssembly workloads and in the standard Kubernetes way, where you define the spec section, define the image name. Just one thing you need to add is the runtime class name. So you need to specify that we need to tell the Kubernetes API server that this particular, workload that we want to run on this particular Kubernetes cluster has to be run on WasmEdge runtime. So let's create this. So it's created. And also you can see, since it is Talos, so it already gave me the warnings, because this is coming from the integrated CIS benchmarks. Right now we put it as warnings because we want people to at least know that, there is something which is not as per the CNCF benchmarks that they can, rectify. Now kubectl, let me clear the screen. kubectl pods, it should be giving me completed kubectl logs, and we should be able to see hello WasmEdge community. So that's how simple it is. Now you can run WebAssembly workloads natively on Civo Kubernetes, Talos clusters. We'll be adding more shims, but WasmEdge was the first shim that I contributed to the extensions. We can add more extensions. And I mean, if any one of you wants to add any extensions for any other runtime, you can do that. But right now, Wasm extension is there. And also, if you want to run Talos Kubernetes with extension on any other provider or compute instances or local, you can do that. So you can also do that because it's all open source. Talos is open source, and you can see Talos is open source, and so are the extension. So this is the Talos modern Linux. So that's the Linux operating system, a modern OS for Kubernetes. Like, it's pretty cool. You should definitely check it out. Worth trying. Yeah, that's pretty much it that I had for the demo.